Hello everyone, this is our demo for the closest pair of points project where we compare two algorithms, brute force and divide and conquer. We'll talk about the compilation, input generation and running time analysis in here. So let's talk about compilation and execution first. We begin by compiling and running our main script. So we can see that the script runs both algorithms for multiple input sizes ranging from 10,000 to 55,000. The output displays a detailed table with theoretical running time, empirical measurements from actual execution ratios, and predicted values using fitted constants C1 and C2. Let's see the output table that we get. This is the output table that we get. So here are the data set that ranges from 10,000 to 55,000, and this is the theoretical runtime for the brute force, and this is the empirical runtime, and this is the ratio for both, and this is the predicted runtime for the brute force, and same for the divide and conquer, and these are the constants C1 and C2. And let's talk about input generation and consistency. So the input for both algorithms consists of randomly generated 2D points. We use a fixed random seed to ensure that the same output and input is given to both the brute force and divide and conquer methods. This is handled in the generate points function. We also verify that the distance returned by both algorithms are nearly identical. This ensures correctness and fairness in the comparison. So here we can see in the code, we used the brute force closest pair of algorithm in here, and this code explains the divide and conquer closest pair algorithm, and here we generate the distant random points, and this is the theoretical running time, and finally right here we create the constants C1 and C2, and those were the explanations for the code. And when we get into average running time, for each input size, the experiment is run for about 10 times. The function run_experiment records the running time in milliseconds for both methods and computes the average. This reduces noise due to system load or randomness and gives a more accurate view of each algorithm's performances. And when we get into the results and the visualizations, let's talk about some graphs that we get. So this is the graph that we get for the divide and conquer. This is empirical and predicted running time. So the black one that we see here is the empirical time, and the yellow one, the orange mostly. The one that we see here is the predicted running time. This is for the divide and conquer. And right here we can see that we have the brute force algorithm, which is and also here also the black line is the actual brute force runtime algorithm, and the predicted time would be represented by the orange line. And when we actually compare both the empirical running time of both algorithms, this black line is the brute force empirical runtime, and the orange one is the divide and conquer empirical runtime. We can observe that as the input size increases, the brute force running time grows very quickly, whereas the divide and conquer grows much slower, showing that it is more scalable for large inputs. So in short, we can say that the divide and conquer is much more efficient than brute force as input size increases. Thank you so much. So this is what we learned from this project. Thank you.